Hi everyone, welcome to my channel Size Up. So today we will be discussing load balancing. It's another video in the series for distributed systems and learning the basic concepts for any distributed system. So before I begin, I request that you like, subscribe, and share my videos and leave a comment just on the content of what you would like to see in the future or whether you like the content that I'm producing. Hopefully these will help you prepare for any fan company interviews or even for general knowledge to understand how distributed systems work, or even for other interviews if you're working in the IT field. So now let's get started with load balancing. So load balancer is another critical component of any distributed system. It helps to spread the traffic across a cluster of servers to improve responsiveness and availability of applications, websites, or databases. So load balancers also keeps track of the status of the resources while distributing requests. So if a server is not available to take a new request or is not responding or has elevated error rate, the load balancer will stop sending traffic to such a server. So typically a load balancer sits between the client and the server, accepting incoming network and application traffic and distributing the traffic across multiple backend servers using various algorithms. By balancing application requests across multiple servers, a load balancer reduces individual server load and prevents any one application server from becoming a single point of failure. So this improves the overall application availability and responsiveness. So to utilize full scalability and redundancy, we try to balance the load at each layer of the system. So there are load balancers that are inserted in three specific places. So the first is between the user and the web server. The second is between the web servers and an internal platform layer like an application server or cache server. Third, it's between an internal platform layer and the database. So the benefits of load balancing, there are 5 major benefits of load balancing that you should talk about for any interview purposes. So the first of which are users experience faster uninterrupted service. So users won't have to wait for a single struggling server to finish its previous tasks. Instead, their requests are immediately passed on to a more readily available resource. The second benefit of a load balancer is that the service providers experience less downtime and higher throughput. Even a full server failure won't affect the end user experience, as load balancer will simply route the traffic around to a healthy server. The third benefit is that load balancing makes it easy for system administrators to handle incoming requests while decreasing wait time for users. The fourth is that smart load balancers provide benefits like predictive analytics that determine traffic bottlenecks before they happen. So as a result, the smart load balancer gives an organization actionable insights. So these are key to automation and can help drive business decisions. The last benefit that you should mention is system administrators experience fewer failed or stressed components. Instead of single device performing a lot of work, load balancing has several devices perform a little bit of work. So now there are algorithms that are used. So before we dive into that, the question is, how does the load balancer choose the backend server? So the load balancers consider 2 factors before forwarding a request to the backend server. So they will first ensure that the server they choose is actually responding appropriately to requests, and then use a pre-configured algorithm to select one from the set of the healthy servers. Now let's discuss what health checks are. So load balancers should only forward traffic to healthy backend servers. To monitor the health of a backend server, health checks regularly attempt to connect to backend servers to ensure that servers are listening. So if a server fails a health check, it is automatically removed from the pool, and traffic will not be forwarded to it until the responses are healthy again, and until they pass the health checks again. So there are various algorithms used for load balancing. The most important are 6 of them, which I will discuss now. So there is a least connection method. So through this method, it directs the traffic to the server with the fewest active connections. So this approach is quite useful when there are a large number of persistent client connections which are unevenly distributed between the servers. The second is least response time method. So this algorithm directs traffic to the server with the fewest active connections and the lowest average response time. The third is the least bandwidth method. So this method selects the server that is currently serving the least amount of traffic measured in megabytes per second, or Mbps, as it's called for short. The fourth would be round-robin method. So this method cycles through a list of servers and sends each new request to the next server. So when it reaches the end of the list, it starts over at the beginning. So for example, you have 3 servers, A, B, and C. So first request will go to A, the second request will go to B, and the third will go to C. So when the fourth request comes in, it will again go to A. So think of it like a full circle, like a round robin. So this technique is most useful when the servers are of equal specification and there are not many persistent connections. Then you have the weighted round robin. So the weighted round robin scheduling is designed to better handle servers with different processing capacities. So each server is assigned a weight, an integer value that indicates the processing capacity. So servers with higher weights receive new connections before those with less weights, and servers with higher weights get more connections than those with less weights. Then the last is the IP hash technique. So under this method, a hash of the IP address of the client is calculated to direct the request to a server. Now, let's move on to the topic of redundant load balancers. The load balancer can be a single point of failure too, if you think of it. So to overcome this, a second load balancer can be connected to the first to form a cluster. So each load balancer monitors the health of the other, and since both of them are equally capable of serving traffic and failure detection, in the event the main load balancer fails, the second load balancer takes over. Now, I will list a few links that you should go over to understand load balancing better, but at a high level, it essentially distributes the traffic so that you have better availability for your system. So for today's video, that is it. I hope you like, subscribe, and share my videos. I want to create more content that would be useful for interview preparation. So if you have a topic in mind you would like more information on, then please reach out to me. And second, I know I usually stare at a screen. I'm currently recording all my videos on my Mac without any special equipment. But in the future, as I get more subscribers and create more content, I hope to move down that route. So for now, bye.